Question number 9. The lambda for H alpha line of Balmer series is 6500 angstrom. What is the lambda of H beta line of Balmer series? Let us solve this question. For H alpha line of Balmer series means Z equal to 1 and N1 equal to 2 and N2 equal to 3. For H beta line, Z equal to 1, N1 equal to 2, N2 equal to 4. Therefore, 1 upon lambda H alpha is equal to RH into, within brackets, 1 upon 2 square minus 1 upon 3 square. And that is equal to 5 RH upon 36. Mark it as equation number 1. And similarly, 1 upon lambda H beta is equal to RH multiplied by, within brackets, 1 upon 2 square minus 1 upon 4 square. That comes out to be equal to 3 RH upon 16. Mark it as number 2. Therefore, lambda H beta upon lambda H alpha will be equal to 5 RH upon 36 into 16 upon 3 RH. That comes out to be equal to 80 upon 108. Or lambda H beta will be equal to 80 upon 108 into lambda H alpha. And this is equal to 80 upon 108 into 6500. On solving, this comes out to be 4814.8 angstrom. And that's the answer of this question. Question number 10. The angular momentum of an electron in a Bohr orbit of hydrogen atom is 4.2178 into 10 to the power minus 34 kilogram meter square per second. Calculate the lambda for the spectral line when this electron falls from this level to next lower level. RH is given to be equal to 1,09,678 centimeter inverse. Let us solve this question. Since we know MVR equal to NH upon 2 pi, therefore 4.2178 into 10 to the power minus 34 is equal to NH upon 2 pi, or N equal to 4.2178 into 10 to the power minus 34 into 2 into 3.14 divided by 6.6 into 10 to the power minus 34. On solving, this comes out to be equal to approximately 4. Therefore, 1 upon lambda will be equal to 1,09,678 multiplied by 1 upon 3 square minus 1 upon 4 square. Solving this, we get lambda equal to 1.8 into 10 to the power minus 4 centimeter, and that becomes the answer of this question. Now we shall discuss the modern model about atomic structure, that is wave mechanical model. This model is based on the following 3 important concepts. Number 1, de Broglie's hypothesis of dual nature of matter. Second, Heisenberg uncertainty principle. Third, Schrodinger's wave equation. Let us learn them one by one. So number 1, de Broglie's hypothesis. In 1924, Louis de Broglie suggested that all particles of matter must have dual nature like light. Thus, according to him, Each particle, whether big or small, is a particle as well as a wave. The wavelength of the matter wave is given by lambda equal to h upon p, and that's equal to h upon m into v, where p is momentum of the particle and that's equal to mass into velocity m into v. So when we put h equal to 6.626 into 10 to the power minus 34 joule second, or sometimes approximately as 6.6 into 10 to the power minus 34 joule second, mass m of the particle in kilogram, and velocity v of the particle in meter per second, then the value of lambda will be in terms of meters m. For example, here is question number 1. Calculate the wavelength of a 100 gram rubber ball moving with a velocity of 100 meters per second. Is the wavelength of ball short enough to be observed? The solution is, since lambda is equal to h upon m into v, substituting the values we have 6.626 into 10 to the power minus 34 joule second divided by 100 into 10 to the power minus 3 kilogram into 100 meter second inverse. On solving this, it comes out to be 6.626 into 10 to the power minus 35 meters, or 6.626 into 10 to the power minus 26 nanometers.